Today, we are continuing on with circular motion and circular motion type problems. So, things that you might want to have on here, besides the fact that, hey, these are your formulas that you're going to wind up using for the most part, is to know what their units are. So, for frequency, you're looking at hertz. For period, we want it in seconds. Velocity, tangential speed, linear velocity, all the same thing, meters per second. I have two of those equations up on the board here. Acceleration, meters per second squared, and centripetal force is going to be in newtons. Anything else that we may need? Well, mass is in kilograms, and the radius we want in meters. All right, so we read this. You got a 3.4 kilogram bucket of water that is attached to a 1.2 meter rope. The bucket has a tangential speed of 3.5 meters per second. What is the centripetal force that keeps the bucket moving in its circular path? So they pretty much just straight up said to us what we want. They want a centripetal force, so we need mv squared over r. We have m of 3.4 kilograms. We have a radius here. So I've gotten a question before, wouldn't that be the diameter? No, because if the I'm going to draw a very, very bad picture here, so I apologize. I think that's a bucket. All right, and you got the little handle thing, and so the rope that is attached to it is 1.2 meters long, and as this thing is spinning, you would see that, right, that would be a radius, not the whole thing. So if you get a problem like that, don't freak out and be like, oh, well, that's the diameter. Nah. All right. So we have a radius then of 1.2 meters. And we got a tangential speed, linear speed, tangential speed, all the same thing. That's V, and that is 3.5 meters per second. So we have everything that we need. And let's put them in the correct positions on in the formula here. Mass, 3.4. Velocity is 3.5. Now you have to square velocity, and you're only squaring velocity. Okay, so I would do it like this. 3.5 squared equals 12.25 times 3.4, and then equals, and then divide by 1.2, and I get an answer of 34.7083, blah, blah, blah. I'm going to give like 2 decimals here. I'm going to call it 34.71. The unit would be newtons. So the rest of these guys, the rest of the problems are more so identifying what variables you have and then what they're looking for, and you're going to wind up solving through. Okay, so they want centripetal acceleration. So you're looking for that, which is v squared divided by r. Make sure you have them. Okay, yes, you got a radius, you have a speed. Okay, sweet. Here, okay, we have a radius, we have a velocity, we have a mass. They want centripetal force. In 4, they want centripetal force for each of these things. All right, so you have a mass, you have a radius, you have a velocity, you have a mass, radius, velocity. In the past, okay, like I've done this on a quiz, I've had a problem just like this. They don't pay attention. They just literally would be like, oh, mv squared over r. They think it's in order, so they would do 1.5 times 0.25 squared divided by 3. Meters per second's velocity, so it'd be 3 squared times 1.5 divided by 0.25. So that is what you're looking to do here for number 4. Number 5, they want centripetal acceleration. Number 6, same thing. They want centripetal acceleration. And in both cases, you are going to have them. Next problem. Centripetal acceleration again. Now, number 8. They're asking you to calculate the tangential speed of 3 separate horses on a merry-go-round. Now, they all complete 1 revolution around the track in 9 seconds. I underline that specifically. So based off of, all right, last week and yesterday, what does that underlined statement mean? Well, frequency, if you remember, is the number of cycles per second. How many, laps, how many rotations, revolutions you're doing per second when we want it in hertz. If you're given RPM, you got to divide it by 60. But period is the time it takes to do 1 complete rotation or revolution or spin, circle, lap. So what they actually give us here is a period of 9 seconds. But then some people are like, well, okay, what's the period for the horse on 7 or the horse that's 12 meters? Now, if you remember, when we, from the notes, if you have, all right, the horse on a carousel or merry-go-round, whatever the heck it's called, they're all on the same rail. Okay, here would be your 3.5, your 7, and 12 meters. They're all going to move around. So if I can, let me see if this works. It's close enough. All right, this thing is going to move around, and they're all going to complete, all right, the same amount of revolutions or spins, rotations, in the same amount of time. So the period for all 3 horses is the same. So you may want to make that note, okay? And then once you know that, well, what is the equation for our velocity, centripetal force, tangential velocity? Jesus. Tangential velocity or speed. The equation that you're going to use is V is equal to 2 pi times R divided by T. So we would do it like this. 2 pi times R of 3.5 divided by 9. Crank this out in a calculator. And you're looking at about 2.44 unit, which would be meters per second. So then you're repeating the process. It's just that they're going to have the same period. So t is going to be 9 on each of these. All right, number 9. A rope is attached to a tire hanging on a tree branch. You got a girl swinging on the tire, and we know this has a centripetal acceleration of 3.2 meters per second squared. So meters per second squared, that is, all right, a centripetal acceleration. Now the rope has a length of this 4.1 meters. All right, so then that's telling us our radius. All right, so what the heck do we do? They want to know how fast the girl's moving. So that's a velocity. So we have to come up with or find the equation that has all three of those things in common. And bam. So we're going to do velocity is equal to the square root of centripetal acceleration times the radius. And then you're just looking at so you're going to do 3.2 times 4.1, 13.12, square root that, and you're cranking out an answer of about this. All right, now the next thing. You have a carnival ride that has a 2-meter radius and it rotates once in 9.9 seconds. They want you to find the speed of the rider and then the centripetal acceleration. So V and then centripetal acceleration. Okay. So velocity, what do they give us? They just give us that we have a radius of 2 meters. And again, because they're saying it rotates just once in this time frame, that is a period. So the period is 0.9 seconds. So with these two pieces of information, we can find velocity using the equation on the front. V is equal to 2 pi r over t. Okay, so let's do this. 2 pi times 2 divided by 0.9. You're looking at 13.9626 meters per second. So that's your answer to part A. Now for part B, to find the centripetal acceleration, you're going to use V, which you just solved for. So you would need to do this 13.96 squared over the radius, which is 2. And yours should be in the ballpark here of 97.44 unit. Meters per second squared. So in this, I asked it to be done a specific kind of way. So a cement mixer that has a radius of 2.5 meters and turns at a frequency of 0.02 hertz. They want to know what the centripetal acceleration is. Okay. Well, first thing I asked for was the period. And on the front side, period is equal to 1 over F. We have F. So you would do 1 over 0.02 hertz. And that is going to give us a period of 50 seconds. So that's the first thing. Then I asked you to solve for velocity. And that is 2 pi r over t. So we're doing 2 pi times, what was our radius? 2.5. And then divided by the period of 50 seconds. Now, yeah, this is going to be a relatively small number. So 2 pi times 2.5 divided by 50. 0.314 and change. So we're just going to say, just call it 0.31 meters per second. So that is the velocity. And we needed to do that because we need that in order to solve for our centripetal acceleration, which is v squared over r. And by throwing this in here, we have 0.31 squared over 2.5. All right, and I come out with 0.03844. I'm going to leave it like that. Okay, so number 12 here. You have a 3.4 kilogram bucket of water attached to a 1.2 meter rope. So same bucket from problem 1, except they're not giving us a tangential speed here. They're just telling us that by swinging this around, it completes 27 revolutions per minute, which would be 27 RPMs. From the notes yesterday, and just by here, we don't want it in RPMs, we want it into hertz. So to get it out of RPMs and into hertz, you're going to divide that by 60. So frequency is actually going to wind up being 27 over 60, which is exactly 0.45 hertz. Okay, so we have frequency. Once you have frequency, you can solve for period because they're the inverses of one another. So t is equal to 1 over f. So we're doing 1 divided by this 0.45. And that comes out to be 2.22 repeating, so we're just going to call it 2.22. The unit for period on the front, we put those on there before. That would be in seconds. All right, bet. So now we have these two dudes. We have F. We have period. Now, solve for velocity. Okay, sweet. What is the equation for velocity? Two pi r over t. We have all of those now. We have t. We have the radius of 1.2. So let's crank this out. 2 times. Oh, didn't want to do it like that. 2 pi times 1.2 over the period, which was this 2.2 seconds. Okay, I get 3.396, so I'm going to call that one 3.4. And that would be in meters per second. And then the last one, centripetal force, which is just m v squared over r. So we have v, we just solved for it. We have r, which was given, and we have m, which was given. So you have to put each other in, you have to put them in the right spot. So we have 3.4 times 3.4 squared, because you have to square the velocity. And then that is going to be divided by the radius here of this 1.2. So 3.4 squared times 3.4 divided by 1.2. And I come out with 32.7533 repeating, so we're going to round it 2 decimals. And we are going to have an answer here of 32.75, and the unit for force is newtons. Heck yeah. All right, so then this takes us to the other pieces here. So on it, we're going to have a quiz tomorrow, and on this, we just want to make sure that we are understanding between a couple different terms, are familiar with problems and their variables. And then there's a question, there's probably going to be a question or two that deals with this kind of scenario. So we have basically, all right, our horses on a rail, A, B, C, D, except we have a meter stick, which is mounted to this little turntable that rotates. We have identical metal washers that are hanging at these different positions. And then this thing is spun around. Here it wants you to rank them from the greatest to the least for the two following quantities. Okay, rotational speed and tangential speed. So I'm going to just draw like an overhead view. Okay, so we have A, B, C, and D. And I'm only going to just show this little sliver here. As this thing is getting rotated around, sorry for not the greatest drawing, but hopefully you get the idea. Rotational speed. Okay, which horse or which washer would go around faster? Would any of them make more laps around? No, because rotational speed is going to be the same for everything that is on this same rail, essentially here. All right, if this thing is spinning uniformly, which is what we are assuming, unless told otherwise, rotational speed is going to be the same. So it's the same, or we could write it out, and we could write it out like this. A is going to equal B, which equals C, and which equals D. But our tangential speed, again from the notes, if you remember that, the farther you are from the center, all right, so as your radius increases, so does your tangential speed. In this case, the greatest would be D, and if you look at this point in the rotation, if we were to clock the meter stick here and then look, we would wind up with D having to cover the furthest distance. So we would have D is greater than C, which is greater than B, and B is greater than A.
You disconnected halfway through.
Well, that's not very good. Give me 1 second. And then we have our definitions. So you have rotation, axis, revolution, rotational speed, tangential speed, period, frequency, and centripetal force. So the motion, I don't know, let's see. Object, speed of an object moving along a circular path. We got to be careful because there's tangential speed and rotational speed. So the rate an object rotates around a circle, that would be your rotational speed. Tangential speed would be A. So we got these two. Force keeping something moving in a circle, that's centripetal force. Motion about an axis, or motion around an axis that's located within the body. That, if you go back just to the notes, is your rotation. So that would be letter D. The motion, or the point at which an object rotates around, that would be your axis. Number of revolutions per second, which is your frequency here. Time it takes to complete one is period, and then the last guy here, the motion when around the axis that's located outside the body, that would be your letter H. All right.